The next topic in this unit is graphing with characteristics. The coefficients in quadratic equations have relationships with graphs. Three characteristics of a graph are found from these relationships: the axis of symmetry, the vertex, and the y-intercept. How do you determine the axis of symmetry just by looking at the equation? Well, the formula for the axis of symmetry comes from a special relationship between the coefficients of the equation y equals ax squared plus bx plus c. The distance between the y-intercept on the parabola and its mirror point is going to be negative b over a. So in this equation, I take b, I change the sign, and divide it by a. That number is the distance between the y-intercept and its mirror point. Remember, the mirror point is mirror points have the same y coordinate, and they're equally distant from the axis of symmetry. So if this is the axis of symmetry, the distance from here to the mirror point is the same as the distance to the y-intercept. Also, the axis of symmetry is half the distance between the y-intercept and its mirror point. So we can determine the axis of symmetry by taking the distance, negative b over a, and dividing it in half. So notice this is negative b over 2a. So in other words, if you want to determine the axis of symmetry just by looking at the equation, take the coefficient of x and divide it by 2 times this number, the coefficient of x squared, and change the sign. If it's negative, make it positive. If it's positive, make it negative. This is an important one to remember. Just by looking at the coefficients, we can determine the axis of symmetry. Relating the axis of symmetry and the vertex using the coefficients, we see that the axis of symmetry, x, of any quadratic equation in the form of y is equal to ax squared plus bx plus c is found in the expression x is equal to negative b over 2a. To find a vertex, substitute x equals negative b over 2a into the quadratic equation to solve for y. In other words, whatever this number is, we take this number and replace x with that number, and we will get a number for y. That's going to give us the y coordinates, the x and y coordinates for the vertex. Another important point on the parabola is its y-intercept. The y-intercept is the point on the graph where x is equal to 0. It's also the place where the graph crosses the y-axis. To find the y-intercept, we substitute 0 in for x into the quadratic equation to get the following. Okay? Here's the general quadratic equation. Replace x with 0, and we end up that y is equal to c. So the y-intercept of any parabola is located at 0, c, where c is the constant term of the general quadratic equation. Example number 1. Determine the axis of symmetry, the vertex, and the y-intercept of the parabola y is equal to x squared plus 3x. Recall that the general form of any quadratic equation is y is equal to ax squared plus bx plus c. Let's identify the relevant coefficients. The coefficient of x squared is 1, so a is equal to 1. The coefficient of our x term is b, which is 3. And c, there is no constant term here, so c is equal to 0. Now that we've identified the coefficients, let's apply this into our formulas we developed so far to get the axis of symmetry, the vertex, and the y-intercept. Given that a is equal to 1 and b is equal to 3, the axis of symmetry is x is equal to negative b over 2a. So knowing that b is equal to 3, I replace b with 3 right here. And knowing that a is equal to 1, I replace a with 1. Doing the arithmetic, we see that the axis of symmetry occurs at negative 3 over 2, or in decimal form, it's negative 1.5. To find the vertex, we substitute x equals negative 1.5 and solve for y. So we take x right here, and we replace x with negative 1.5 right here and here. Doing the arithmetic, we see that y is equal to negative 2.25. So the vertex occurs at negative 1.5 and negative 2.25. Now recall that c is equal to 0. So the y-intercept is found at 0, comma c, but since c is equal to 0, the y-intercept is going to be at 0, 0. Graphing with characteristics. To graph y equals ax squared plus bx plus c, locate and plot the following points. Our first step is to determine the axis of symmetry. The equation for axis of symmetry is going to be x is equal to negative b over 2a, where b is the coefficient of x. So what I do is I take this number and I change the sign. Then I divide it by twice this number, the coefficient of x squared. That's where the axis of symmetry is going to be located. Next, we determine the vertex point. The vertex point is going to be this number for the x-coordinate, and then I take this number and plug it into here to figure out what y is going to be. We'll make that more concrete when we look at the example. Now, to graph a parabola, we want to get 5 points. We get the vertex point, then we're going to get a mirror point with, this is where the y-intercept is going to be with its mirror point, and then the next point is going to be somewhere up here and its mirror point somewhere over here. So generally speaking, we want to get at least 5 points to graph a parabola. Our first point is going to be the vertex point. The next one is going to be the y-intercept. That's going to be 0, and whatever this number is going to be is the y-coordinate. Next, we calculate the mirror point of the y-intercept, which is going to be negative b over a, comma c. Okay, so we take c here, and then what we do, this is a little different. Notice this is 2a, this is just a, so make a note of that. The mirror point is going to be negative b over a, comma c, where the x-intercept, x-axis of symmetry is b over 2a, negative b over 2a. So make a note of that. So here we got 1, 2, 3 points. To get the other two, we're going to choose another point on one side of the x-axis that is a solution to the equation and locate its mirror point. So we pick one point here, locate its mirror point, and now we have 5 points, which is enough to graph a parabola. So then our final step will be to connect the dots. In example 2, we're going to practice by graphing y is equal to 2x squared minus 4x minus 3 using the characteristics of the coefficients. We're going to locate the axis of symmetry. That's going to be our first step. And we do this by using the general formula, x is equal to negative b over 2a, where b is the coefficient of x. So b is negative 4, so I replace b with negative 4. And a is equal to 2, so I replace a with 2. Now it's 2 times a, and another thing I need to point out is that there is a negative here. So 2 negatives are going to make a positive. And when I combine 4 over 4, this is equal to 4, the axis of symmetry is going to be the line x equals 1, which we see here designated by this red dotted line at x equals 1. Our second step is to find a vertex. So locating the axis of symmetry at x equals 1, we would substitute into this equation. Everywhere we see x, we replace x with 1. And completing the arithmetic, we find out that y is equal to negative 5. So the vertex occurs at 1, negative 5, designated by this point here. Now that's 1 point. To graph a parabola, we need 4 more. We want a total of at least 5 points to graph a parabola. So let's go ahead and find 2 more. Our third step is to locate the y-intercept. Now, generally speaking, the y-intercept occurs at 0, comma c, where c is the constant term of our general equation right here. So I replace c, I know c is equal to negative 3, so I replace c with negative 3, and we get the y-intercept at 0, negative 3. So I go here, and I graph the point 0, negative 3 for my y-intercept. Okay, we have 2 points. Let's find another, which takes us to step 4. Locate the y-intercept mirror point. Now, the mirror point is located at, the y-coordinate is going to be c. The x-coordinate is going to be negative b over a. Here's negative b. Oops, wrong one. Here's negative b, negative 4. So I replace b with negative 4. And the coefficient of x squared is 2. That gets replaced with a. And don't forget, we got two negatives. Negative times negative is a positive. So working all this out, this is going to be 2. So the mirror point occurs at 2, negative 3, which is located right here. So now we have 3 of the points. We just need 2 more. Step number 5, we choose another point on one side of the axis that is a solution to the equation and locate its mirror point. We can select any number we want. Logically speaking, I'm going to select x equals negative 1 and solve for y. The reason why I'm choosing x equals negative 1 is because if you look at the way the points go and down in order, we have x equals 2, x equals 1, x equals 0. So the next logical choice on this graph would be x equals negative 1. Okay, let's make that substitution. So I put x equals negative 1 in for x here. And I also put it in for x over here. Completing the arithmetic, we have y is equal to 3. So we're going to plot the point negative 1, 3, which is right there. Now the mirror point of negative 1, 3 must be the same x distance, the horizontal distance, which is 2, okay, 1, 2, from the axis of symmetry as the selected point. It will have the same y value. So if I consider this, okay, we have 1 plus 2 is 3, so the y value is going to be 3. In other words, I look at it this way. Here's the axis of symmetry, which is at 1. I go 2 to the right, which is the x coordinate is going to be 3. The y coordinate is going to be the same, so the mirror point is going to occur at 3, 3, right here. So just to recap, I took x coordinate equals negative 1. I put it into the equation and got the point negative 1, 3. This is 2 units away from the axis of symmetry, so the mirror point is also going to be 2 units away from the axis of symmetry, which is the coordinate 3, 3. We now have our 5 points, so we can connect the dots, step 6, knowing that we have the axis of symmetry at x equals 1. The vertex is at 1, negative 5. The y-intercept is at 0, negative 3. The y-intercept mirror point is 2, negative 3. And one more point with its mirror point occurs at negative 1, 3 and positive 3, 3. These 5 points combine with a smooth curve to form a parabola.